All right, strap in everyone, because today we're heading to Singapore.
To see how they're using open source to teach physics.
Yeah.
Yeah.
Specifically,
Mhm.
easy Java simulations,
Yeah,
or EJS, as I hear the cool kids call it.
exactly.
And we're not just talking about, like, using some software, right?
Yeah, I know.
These teachers are actually creating their own
Yeah.
lessons and simulations.
Yeah, we've got a blog post,
Okay.
event details. We even have some feedback
Nice.
from a workshop with teachers who are already using EJS.
So, can we back up for just a sec?
Yeah.
What is EJS?
Right.
And why should we even care about it?
So imagine you can build
Okay.
interactive physics models, like simulating gravity,
Wow.
motion. You can even do things like planetary orbits.
Wow.
And EJS lets teachers do just that.
Hmm.
And the best part, it works on like everything.
Really?
Windows, Mac OS X, Linux, you name it.
That is impressive.
Yeah, and it's not like some expensive software that's going to break the bank.
Okay.
It's open source, which means it's free
I like free.
to use. Anyone can adapt it.
So it's like a physics playground for teachers.
It is. They can basically create whatever lessons they need for their students.
So is this where this whole constructivism thing comes in?
Yes, that's it.
I keep seeing that word.
Oh,
What does
yeah.
that even mean?
Well, constructivism basically means that students learn best by actually doing things,
Okay.
like by building and creating things.
So not just like reading a textbook.
Right.
They're actually
Exactly.
making stuff.
Exactly.
Okay, I like that.
Yeah, with EJS, they could like build a virtual pendulum to
Cool.
really understand how oscillation works. It's pretty cool.
Yeah, that's way more engaging than just,
Definitely.
memorizing a formula.
Yeah,
You're actually understanding how it works.
sure.
Okay, let's talk about this workshop.
Yes.
I read that it had a pretty interesting format.
It did. It followed what we call a flipped classroom model.
Okay, now I'm definitely lost.
So basically, the teachers watched videos before the workshop to get some background knowledge.
Okay, I can understand that.
And then during the workshop, they jumped right into hands-on activities.
So less talking, more doing.
Exactly.
I like it.
Yeah. And they even gave the activities fun names,
Like what?
like starter, requester, beginner, remixer, and even a sharer activity.
Okay, someone was having fun naming those.
This sounds like it.
So they were learning by building up their skills as they went along.
Yeah.
I like that approach.
Me too.
Were there any, standout moments from the workshop that you saw?
Oh, definitely.
Okay, tell me.
They actually added a brand new activity.
Ooh, fresh content.
Yeah.
What was it?
Where the teachers had to modify an existing simulation by adding a timer.
Interesting. Why'd they do that?
Well, apparently it came from a real-world challenge that a teacher was actually facing.
So they're really listening to the teachers and what they need?
Yeah, they're constantly trying to make the workshop better.
That's awesome. And the fact that all the materials, including that, what was it called?
Modeling worksheet?
Yeah, the modeling worksheet.
Yeah.
That's all available for download.
It is.
That's pretty generous.
Well, that's the beauty of open source, right?
True.
Sharing is caring?
Okay, but no project's perfect, right?
No, of course not.
Were there any hiccups with the workshops?
Well, one thing they mentioned was that they had a limited number of laptops.
The classic tech problem.
It happens.
Yeah. Even with the best intentions, sometimes logistics get in the way.
For sure.
But overall, it sounds like the feedback was super positive.
It was. The teachers were raving about it.
What were they saying?
Let me see.
Okay.
Oh, here's one. Someone said, Liu Kang's passion and enthusiasm is infectious.
Oh, that's sweet.
And then another teacher said that the tasks felt authentic and much more enriching than abstract concepts.
See, that's what I love about this.
Yeah.
It's not just about some cool tech tool. It's about changing how we think about teaching physics.
Totally agree.
But, there's always room for improvement, right?
Always.
What did the teachers say could be better?
Well, some of them felt that the workshop was a bit too fast-paced,
Really?
given how much information they were trying to cover.
Yeah, I could see that.
They wished they had more time to really absorb everything.
That makes sense.
Some even said that they would have preferred if it was spread out over a couple of days
Intriguing.
instead of just a single session.
Yeah, you can't rush a deep dive.
Exactly.
It seems like they're hungry for more.
Oh, definitely. They want to explore EJS further.
So, out of all of this feedback, what would you say is the biggest takeaway?
I think the thing that really resonated with the teachers was the control and customization that open source offers.
Okay, so they like that they could tinker with it
Yes.
and make it their own
Exactly.
instead of just using something that's pre-made.
Exactly. They can adapt it to their students' needs and even share their modifications with others.
That must be really empowering.
It is. It totally flips the script. Instead of being passive consumers of knowledge,
Okay.
they become active creators.
I'm starting to get why everyone's so excited about this.
It's pretty exciting.
But is this just a Singapore thing?
Oh, no, no, no.
Or is this happening all over the place?
It's global. There's this movement called the Open Education Resource Initiative.
Okay.
And they're all about creating and sharing educational materials for free.
Wow.
And it's not just physics. This is happening in all kinds of subjects.
Okay, so we've established that EJS is pretty awesome for physics.
It is.
But could this open source approach work for other subjects too?
Oh, absolutely.
Give me some examples.
Think Jetterbrev for math.
Okay.
You can create interactive math explorations. Or how about Molecular Workbench for chemistry? You can actually visualize complex chemical reactions.
Okay, now we're talking.
Right. The possibilities are endless.
All right. We've covered a lot of ground already in this first part of our deep dive.
We have.
And I don't know about you, but I am ready to take a break.
Me too. Let's take a breather, and then we'll come back and explore even more about how EJS is being used in classrooms.
And what this all means for the future of learning.
Exactly.
Stay tuned. All right, welcome back, everyone. I'm still buzzing about this whole open source thing.
It's pretty exciting stuff.
It is. You mentioned that EJS isn't just for physics.
Right.
But what really got me thinking is how teachers are using it to, actually become creators.
It's a whole new way of thinking about teaching, isn't it?
Yeah, it's like they're not just delivering the information. They're actually shaping the whole learning experience.
Exactly. They have so much more control.
But I think the big question is, how?
How what?
Like, okay, you have this open source tool,
Right.
but what does that actually look like in a classroom? How are teachers using EJS to make physics, actually make sense for their students?
Well, think about those classic physics experiments.
Like what?
Like, Galileo dropping objects from the Leaning Tower of Pisa.
Oh, yeah, I remember learning about that.
With EJS, teachers can actually recreate those experiments virtually.
Oh, wow. So instead of just reading about it in a textbook,
Right.
they can actually see it happening.
They can. They can change different variables, test theories, all in real time.
That's pretty cool.
It's like a physics video game.
But they're actually learning something.
Exactly. And it's not just about making it fun.
Right.
Another teacher was saying they use EJS to model planetary orbits.
Like how the planets move around the sun.
Exactly.
Oh.
Students can visualize the gravitational forces, play around with different variables, and see how it all affects the orbits.
So it takes something that's kind of hard to grasp.
Very abstract.
Yeah, abstract, and makes it real.
Makes it visual, makes it understandable.
I like that. But what about those, those aha moments? Like when something finally clicks for a student.
Oh, there are tons of those.
Really?
One teacher told a story about a student who was really struggling with the idea of conservation of energy.
That's a tough one.
It is. So they built this simulation in EJS
Okay.
where a ball rolls down a ramp,
Okay.
and the student could track the potential and kinetic energy at different points along the way.
So they could see how the energy changed.
Yes, and when the student saw that the total energy stayed the same, even though the types of energy were changing,
Oh, I get it.
it was like a light bulb went off.
It finally made sense.
Exactly.
That's awesome.
And that kind of learning, that's powerful.
That sticks with you.
It does.
Okay, so we talked about individual learning, but what about, working together?
Collaboration.
Yeah, collaboration. Can EJS help with that?
Absolutely. It's a great tool for group projects.
How so?
Well, one teacher had their students design a roller coaster in EJS.
Oh, wow, that sounds fun.
It was. The students had to work together in groups. They had to think about gravity, friction, energy, all that good stuff.
To make sure their roller coaster actually worked.
Exactly, and it was safe.
I bet that got pretty competitive.
Oh, yeah, it was a friendly competition, but it also forced them to collaborate,
To communicate, to problem solve as a team.
Exactly.
So they're not just learning physics, they're learning real-world skills.
Exactly.
I love that.
It's preparing them for the future.
Okay, so EJS seems to be pretty good for students.
It is.
But what about the teachers?
Teachers love it too.
How has it changed their teaching, practices?
Well, a lot of teachers are moving away from traditional lectures.
Less talking at the students.
Exactly. They're becoming more like facilitators.
Guiding the learning, not just dictating it.
Exactly. And it's not just about how they deliver information, it's making them think differently about how they teach.
They have to design simulations, create activities, really think about how to present the material.
It's making them better teachers, I think.
So EJS is like professional development, too.
It is. It's a tool for growth.
That's awesome. We keep talking about this global open source movement,
Mm.
but I'm curious, how has EJS specifically brought teachers together in Singapore?
Oh, it's been amazing. They've created these online forums and
Like a
communities.
virtual teachers lounge.
Exactly. They share their simulations, exchange tips, troubleshoot problems.
They're like a built-in support system.
It is. It's really inspiring to see.
Okay, I'm sold. But I have to ask, are there any, downsides to this whole open source thing?
Well, like anything, there are challenges.
Like what?
One of the biggest ones is making sure teachers have the time and support they need.
Right, you can't just give them a tool and say, go.
Exactly. It takes training, resources, and ongoing support.
And what about keeping it going?
Sustainability.
Yeah, who's going to maintain these tools, make sure they stay updated?
That's a big question.
It's not just about the initial excitement, it's about the long haul.
Exactly.
But I mean, if we can figure that out,
Mm-hmm.
the potential is huge.
Oh, it is. It's not just about the practical benefits. It's about changing the whole culture of education.
Making it more collaborative, more innovative.
More equitable.
Okay, I'm convinced.
Good.
But let's get down to brass tacks here.
Okay.
Give me some real-world examples of how EJS is actually being used in Singaporean classrooms.
Let's do it.
Because at the end of the day, that's what matters, right?
Absolutely. It's all about impact.
All right, so let's shift our focus to the classroom
Let's go.
and see how EJS is shaping the learning experience for students in Singapore.
Stay tuned for part 3, where we'll explore those real-world examples and dive even deeper into the amazing world of open-source physics.
All right, so we're back and ready to see EJS in action.
Let's see how it's making a difference in real classrooms.
Yeah, give me some examples
Okay, imagine a classroom where students are actually, doing physics.
instead of just reading about it.
Exactly. One teacher was telling me how she uses EJS to simulate projectile motion.
Oh, like throwing a ball or something?
Exactly. So instead of just plugging numbers into formulas, students get to virtually launch objects.
So they can change the angle
Yeah, adjust the velocity.
and see what happens.
All in real time.
So it's like a video game, but they're learning physics.
Exactly. And it's not just about making it fun, though. That's important, too.
Right.
Another teacher uses EJS to model planetary orbits.
Okay, that's a little harder to visualize.
It is, but with EJS, students can see how gravity affects the planets.
So they can see how the planets would move if, the sun was bigger or smaller.
Exactly. They can tweak the variables and see how it affects the whole system.
Okay, that's starting to make more sense.
Good, good.
But what about those, light bulb moments, when a student finally gets it?
Oh, those are the best.
Yeah,
One teacher told me about a student who was really struggling with conservation of energy.
that's a tough one.
It is, but they built an EJS simulation
Yeah,
with a ball rolling down a ramp.
right.
The student could actually see the potential and kinetic energy changing.
Oh, I see, as the ball rolled.
Yeah, and then the student realized that even though those energies were changing, the total energy stayed the same.
So the energy wasn't disappearing, it was just changing forms.
Exactly. And that's when it clicked for the student.
That's awesome. It's one thing to know the formula, but it's another to actually see it in action.
Totally agree.
Okay, so we've talked about individual learning, but what about teamwork? Can EJS help with that?
Of course. It's great for collaboration.
Give me an example.
One teacher had their students design a roller coaster in EJS.
Whoa, seriously?
Yeah, it was a group project.
Okay.
They had to think about all the physics involved, like gravity, friction, energy.
To make sure their roller coaster didn't fly off the track.
Exactly, and they had to work together to make it happen.
So they're learning physics, but they're also learning how to work as a team.
Exactly. Communication, problem solving, all those essential skills.
It's like a real-world simulation.
It is.
Okay, I'm really impressed with EJS.
Me too. It's a powerful tool.
It's helping students understand physics in a whole new way.
And it's helping teachers become better educators.
But I keep thinking, this all sounds great for Singapore.
Mhm.
But what about the rest of the world? What's the future of EJS and open source education in general?
I think the future is bright, More and more teachers are discovering the power of open source.
They're realizing they don't have to be limited by expensive textbooks and software.
Exactly. Imagine a world where teachers from all over are sharing their EJS simulations.
And collaborating on new projects.
It's already starting to happen.
So we could have this huge library of free educational resources.
That's the goal, to make learning accessible to everyone.
I love that it's about breaking down barriers and giving everyone a chance to learn and grow.
It's about empowering teachers and students to create their own learning adventures.
Well said. We've talked a lot about EJS and open source physics today,
We have.
but I think it's time to turn it over to our listeners.
What do you mean?
I want them to take what we've discussed and think about what it means for them.
Ah, I like that.
So, to our listeners out there,
Mm-hmm.
we've explored the what and the why of open source physics.
We've seen how it's being used in classrooms.
Now we want you to think about the how.
The how for you.
Exactly. What excites you about this? What possibilities do you see?
For your students, for your own learning.
The beauty of open source is that anyone can participate.
You can create, share, and help shape the future of education.
So go out there and explore
Dive into the world of open source.
and see what you can discover.
That's all from us today on The Deep Dive.
Thanks for joining us.
See you next time.